Welcome to the AI Coach by Anil Nathu. It's a fascinating time to be talking about artificial intelligence, isn't it? Every day brings new breakthroughs.
It really does. It can feel like a full-time job just keeping up.
Exactly. But what if we could move beyond just using AI? What if AI could actually, work for you autonomously?
Navigating complex tasks, making decisions, that's the direction things are heading.
That's precisely what we're going to unpack today. We're taking a deep dive into what feels like the next frontier, agentic AI. So imagine intelligent systems that don't just spit back answers to prompts.
Right. Systems that actually act with purpose. They reason over complex goals, maybe even work together with other AI systems.
That's the core idea. And our
Ah,
mission today is to really decode this landscape, specifically agentic AI frameworks, protocols, and tools on AWS. We want to help you understand the foundational bits and pieces you need to build these effective, autonomous AI solutions. How they perceive context, make decisions, take actions.
And for this deep dive, we're grounding ourselves in some really authoritative material. It's the AWS Prescriptive Guidance document on Agentic AI. It's a pretty robust guide, authored by Aaron Semp and Joshua Samuel at AWS, just published in July 2025.
So very current.
Extremely.
Yeah.
And crucially, it's not just theory. This is practical, actionable guidance straight from the front lines of cloud AI development. Think of it as a roadmap.
A roadmap for architects, developers, technology leaders, anyone looking to use these AI agents in cloud application.
Exactly. It's really a blueprint for building these autonomous systems effectively.
Okay, so before we jump into the deep end, maybe a quick overview. The document breaks agentic AI down into three core pillars, right?
That's right. Frameworks, protocols, and tools.
Frameworks, protocols, tools. Okay, maybe think of them as the brain, the language, and the hands.
That's a great analogy. Frameworks provide the structure, the intelligence, the brain. Protocols are the standardized communication channels, the language. And tools are the specific capabilities they use to act the hands.
Got it. Brain, language, hands.
And if we connect this to the bigger picture for organizations, these components are designed to tackle what the authors call undifferentiated heavy lifting.
Undifferentiated heavy lifting. Okay, what does that mean in practice?
It's basically all those repetitive, common tasks that soak up resources but don't really add unique business value. The plumbing.
Right. Setting up basic infrastructure, integration tasks, the stuff everyone has to do.
Exactly. By leveraging these established frameworks, protocols, and tools, organizations can cut down dramatically on that foundational work.
Which frees up teams to focus
On the unique value, the innovation that AI can bring to their specific business, building on a solid foundation instead of reinventing the wheel every time.
That makes a lot of sense. And as we navigate this pretty complex landscape of autonomous AI, it's probably worth remembering that resources like the AI Coach by Anil Nathu are out there
Absolutely. They can be invaluable for demystifying these advanced concepts.
and helping you figure out how to actually apply them to your own strategies, making it accessible and actionable. All right, let's kick things off with the first pillar, agentic AI frameworks. So when we say framework here, what are we really talking about?
Well, think of it as the software foundation, the scaffolding, maybe.
Yeah.
It's what transforms those raw LLM interactions, which are really just text in, text out.
Right, like a chatbot.
Exactly. It transforms that into a robust, genuinely autonomous agent. Without a good framework, you've got a smart chatbot. With one, you're building something that can understand intent, plan, make decisions, and actually take action.
Okay, so it's the engine that drives the autonomy. What capabilities do these frameworks typically provide?
The AWS guidance breaks down several key capabilities that are really essential for true autonomous operation. First up is agent orchestration.
Orchestration, like a conductor.
Kind of, yeah. It's about coordinating the flow of information and decision-making. Maybe within a single complex agent or across a whole team of agents working together. The goal is to achieve complex objectives without needing a human constantly steering things. Breaking down a project, managing steps, ensuring everything happens in the right order. It's fundamental.
Got it. What's next?
Second, and absolutely vital, is tool integration. This is how agents interact with the outside world. External systems, APIs, databases.
So they're not just stuck inside their own brain.
Precisely. They can actually do things. Invoke a database query, update a customer record in CRM, send an email via your company system. It extends their reach beyond just language.
Okay, so orchestration to manage the process,
Yeah.
tool integration to act externally. What else?
Third is memory management. This is crucial. Agents need to remember things just like we do.
Maintaining context.
Exactly. Persistent or session-based state. It allows them to keep track of past interactions, decisions, information gathered over time. Essential for any task that isn't just a one-shot query.
Without memory, they'd just reset every time.
Pretty much. Which severely limits their ability to handle anything complex or ongoing.
Makes sense. What's the fourth capability?
Fourth is workflow definition. This is about supporting structured patterns for how the agent reasons and acts. It allows for more sophisticated logic.
Patterns like?
Things like chains, where tasks run one after another. Routing, where the agent makes a decision and goes down different paths based on the situation. Parallelization, doing multiple things at once for speed. And maybe the most advanced is reflection loops.
Reflection loops.
Yeah, where an agent can actually evaluate its own performance, figure out if it made a mistake, and then adjust its approach. Self-correction, essentially.
Wow, okay. That sounds pretty intelligent.
It's a key part of genuine autonomy. And finally, number 5 is deployment and monitoring.
Right, getting it out into the real world and making sure it works.
Exactly. You need tools to smoothly move agents from development to production, and then critically, you need observability. You have to be able to see what the agent is doing, why it's doing it, track its performance, especially when it's running autonomously.
Absolutely. You need that visibility and control.
Yeah.
So orchestration, tools, memory, workflow, deployment. That's a huge leap from just a language model. These are systems that don't just answer, they do things with awareness, memory, and even self-correction.
It's a foundational shift, definitely.
Okay, let's dive into some of the specific frameworks out there. Where should we start? Maybe with the AWS native option.
Sounds good. Let's talk about Strands agents.
Strands agents. Okay. This is an open source SDK, initially from AWS, right? I think I saw it on the AWS open source blog.
That's the one. Its core philosophy is what they call a model-first approach.
Model first, meaning the LLM is the star.
Pretty much. The idea is that the foundation model is the core intelligence, enabling that sophisticated autonomous reasoning right from the start. It's built specifically for fully autonomous solutions.
And it plays well with AWS services.
Extremely well. That's a key feature. But it's also designed to be flexible. One of its biggest advantages, highlighted in the AWS guidance, is native MCP integration.
MCP Model Context Protocol. We'll get more into protocols later, but that's the standard for agent communication.
Yes, an emerging open standard. Strands Agent supports it natively, which really simplifies how agents share context and interact.
Okay, what else is key about Strands agents?
Well, for organizations already on AWS, the deep AWS service integration is huge. Seamless connections to Bedrock for models, Lambda for serverless compute, step functions for workflow orchestration. You can build complex, autonomous flows right within your existing AWS setup.
Makes sense. And model choice.
Very flexible. It supports various models like Anthropic's Claude and different Amazon Nova models, Premier, Pro, Lite, Micro, all through Bedrock. So you can pick the right level of capability for the job.
So not just AWS models?
No, its LLM API integration is flexible. It works with Bedrock, but also OpenAI and other interfaces, which is important for production choices.
What about handling things beyond text?
It has multimodal capabilities. Text, speech, image processing are supported, so your agents aren't just text bots. And finally, a rich tool ecosystem, especially for AWS services, but it's extensible. You can build custom tools to let your agent interact with almost anything.
Okay, so who is Strands agents really for? When should an organization seriously consider it?
The guidance suggests it's a strong fit if you're already building on AWS infrastructure, obviously. If you need that native integration for autonomous workflows.
And for production systems?
Yes, especially if you need enterprise-grade security, scalability, compliance.
Yeah.
Also, if you need that flexibility in choosing foundation models for specific tasks, or if you require really tight integration with your existing AWS workflows and resources for end-to-end automation.
How hard is it to get started? What's the implementation like?
It's designed to be pretty straightforward, actually, even for less technical folks. The Quick Start Guide shows you can select your foundation models, maybe Amazon Nova on Bedrock. You define custom tools to connect to your systems, handle different modalities, text, images, speech, and then deploy the agents to respond and act autonomously.
And the guidance says this approach lets teams build agents without deep technical expertise in AI model development.
Exactly. It lowers that barrier to entry, which is a big deal for wider adoption.
Okay, let's make this concrete. Is there a real-world example of Strands agents in action?
A great one is AWS Transform for .NET. This isn't just a demo, it's a live production service from AWS itself.
And it uses Strands agents. What does it do?
It's designed to modernize old .NET applications. The fascinating part, described in an AWS blog post, is that it employs multiple specialized autonomous agents.
Multiple agents working together.
Yes. They collaborate autonomously to analyze the legacy code, figure out a modernization strategy, and then actually execute the code transformations to move it to a cloud-native architecture, all without human intervention during the core process.
Wow. That really showcases its capability for complex, real-world enterprise tasks and its production readiness.
Absolutely. It's a clear sign of how autonomous AI can tackle major IT challenges. And getting practical guidance on building systems like that, well, that's where something like the AI Coach by Anil Nathu could really help bridge the gap between the tech and the business application.
Okay, so Strands Agents is the strong AWS native contender. What about frameworks with maybe broader ecosystems or different approaches to workflow?
That brings us nicely to LangChain and LangGraph. These are definitely established powerhouses in the agentic AI space.
LangChain feels like it's been around for a while in AI development terms.
It has. It's probably one of the most widely adopted frameworks. And LangGraph is an extension specifically designed for building those complex stateful agent workflows. Together, they're a very comprehensive solution.
What makes them stand out? What are the key features?
Well, first, a massive component ecosystem, just a huge library of pre-built components integrations, data loaders, tools that really speeds up development.
So lots of building blocks readily available.
Exactly. They also offer broad foundation model selection, supporting models like Claude, the Amazon Nova family on Bedrock, and many others. Their LLM API integration is very standardized, working with Bedrock, OpenAI, you name it.
Multimodal.
Yes, built-in multimodal processing for text, images, audio, which is crucial for richer interactions. But where LangGraph really adds unique value is in graph-based workflows.
Graph-based workflows, what does that mean practically?
Think of it like building a flowchart for your agent's brain. LangGraph lets you define agent behaviors as state machines.
State machines, like defining every possible step and decision.
Precisely. It allows for incredibly sophisticated decision logic, conditional paths, loops, complex reasoning. They also provide strong memory abstractions for managing both short-term context within a session and long-term knowledge.
Which we know is crucial.
Absolutely. And of course, a rich tool integration ecosystem connecting to countless services and APIs. Plus, they offer the LangGraph platform as a managed deployment and monitoring solution, which helps get things into production.
Okay, so LangChain and LangGraph sound powerful, but maybe more complex. When should a team choose this combination?
They're a great fit for really complex, multi-step reasoning workflows where you need that sophisticated orchestration for autonomous decisions.
Like that state machine capability.
Exactly. Also, if your project needs to tap into that huge ecosystem of pre-built components, or if your team already has strong Python ML expertise and wants fine-grained control.
And for long-running tasks.
Yes, definitely. If you need complex state management across long agent sessions where the agent has to remember and act on a lot of history, these frameworks are exceptionally robust.
What's the implementation approach like? Is it all code?
It's structured and graph-based, as you'd expect from LangGraph. You define these workflow graphs, map out the reasoning patterns, integrate multimodal inputs if needed, and build in quality controls.
Does that make it easier to understand what the agent is doing?
That's a key benefit. The graph approach provides, as their docs say, clear visibility into each step of the reasoning process and the ability to audit decision paths. It's much easier to debug and trust a system when you can visualize its thought process.
Let's bring this to life. You mentioned Vodafone using LangChain and LangGraph.
Yes, a really interesting case study. They built internal AI assistants.
Doing what?
Things like autonomously monitoring system performance metrics, pulling relevant information from documentation, and then presenting actionable insights back to the teams, all through natural language.
Okay, streamlining data ops. How did they use the frameworks?
They used LangChain's modular components, document loaders, vector stores for semantic search, multi-LLM support for rapid prototyping, and testing different AI pipelines.
And LangGraph.
LangGraph came in to structure the multi-agent orchestration. They created these modular subagents, each specializing in a task collection. Processing, summarization, reasoning, and LangGraph defined how they work together. Then they integrated this whole system into their cloud environment using APIs, a really solid enterprise deployment.
That's a great example of combining the flexibility of LangChain with the structure of LangGraph. It sounds like the kind of solution the AI Coach by Anil Nathu could help a company architect.
Absolutely. It shows the real-world power of these tools when applied strategically.
Okay, next up in our framework tour, Crew AI. What's the story here?
Crew AI is another open-source framework available on GitHub. Its main focus is on autonomous multi-agent orchestration,
Multi-agent orchestration.
like LangGraph. Similar goal, but a different approach. Crew AI's real differentiator is its emphasis on role-based coordination and task delegation.
Role-based, like setting up an AI team.
Exactly. That's the core concept. You build teams of specialized AI agents that collaborate to achieve a common goal.
How does that work? What are the features?
Its key feature is role-based agent design. You actually define agents with specific roles, goals, even backstories to give them specialized expertise, like creating a researcher agent and a writer agent. It has built-in task delegation mechanisms, so the system can autonomously assign tasks to the agent best suited for the job. And crucially, it provides a framework for genuine agent collaboration.
Meaning they talk to each other.
Yes, autonomously.
Oh.
Sharing information, findings, coordinating efforts without human mediation. Imagine an AI research team where each agent focuses on a different angle and they pool their knowledge.
Interesting. What else?
It supports structured process management for both sequential and parallel tasks. Flexible foundation model selection, including Amazon Nova on Bedrock, versatile LLM API integration with Bedrock, OpenAI, even local models, and emerging multimodal support for text, images, etc.
Okay, so the team of agents concept is central. When would Crew AI be the best choice?
It really shines for complex problems that naturally break down into specialized roles. If your project needs explicit collaboration between multiple autonomous agents,
Like that research team example.
exactly. Or if decomposing the problem into team-based components just makes sense for tackling it. Also, scenarios where you want a really clear separation of concerns between different agent roles, much like departments in a company.
How do you implement something like this? Does it feel like managing a team?
The approach, as detailed in their docs, really mirrors human team structures. It feels quite intuitive, especially for business folks. You define your specialized agents, the researcher, the analyst, the strategist. You assign tasks based on their roles, set up dependencies of workflows logically, and then orchestrate their collaboration.
And the AWS guidance notes this is intuitive for business leaders.
Yes, and that it enables autonomous teams with specialized expertise areas that collaborate, similar to how human teams operate, but with a key difference.
They work continuously.
Right. The autonomous team can work continuously without human intervention. That scale and persistence is a massive advantage.
So could these AI teams actually outperform human teams sometimes? AWS seems to think so, based on their work with Crew AI.
They've certainly put it to the test. AWS implemented multi-agent systems using Crew AI, integrated with Amazon Bedrock, developing what they called a secure, vendor-neutral framework.
What did they build?
A Crew AI case study details this. They released reference designs or blueprints and example systems, things like a multi-agent AWS security audit crew to autonomously find vulnerabilities. Also, code modernization flows, similar to the Strands example, but using Crew AI's team approach.
And consumer packaged goods, CPG, back office automation for streamlining admin tasks.
And did it work? What were the results?
The results are pretty compelling. Early pilots showed major improvements, like 70% faster execution for a big code modernization project,
70%.
and about a 90% reduction in processing time for one of the CPG back office workflows. Huge efficiency gains. Wow, that really demonstrates the potential of these autonomous AI crews.
Definitely. And they also highlighted the importance of observability, integrating with tools like CloudWatch, AgentOps, LangFuse to track what these autonomous teams were doing. Traceability is key.
Okay, let's shift from open source frameworks requiring self-management to a fully managed option. Amazon Bedrock agents.
Right. This is a significant offering from AWS precisely because it is fully managed.
Meaning AWS handles the infrastructure.
Exactly. No need to provision servers, manage capacity, or deal with the underlying plumbing. You build and configure agents without writing tons of custom code.
How does that work? What are its core features?
Well, being a fully managed service is the headline feature. Development is API-driven. You define and run agents by specifying models, instructions, tools via API calls, or the console. A key concept is action groups. These define the specific actions your agent can perform, essentially linking them to external APIs via schemas.
So defining the agent's hands.
Precisely. It also has seamless knowledge base integration with Amazon Bedrock knowledge bases. This is incredibly powerful.
Why is that so powerful?
because it lets your agent access and use your organization's private up-to-date data to answer questions or complete tasks. It's not limited to the general knowledge baked into the LLM. That's retrieval augmented generation, or RDID, built right in.
Got it. Enhancing the agent with proprietary knowledge.
Yes. You can also customize agent behavior using advanced prompt templates for different stages: pre-processing input, orchestrating reasoning, generating responses from the knowledge base, post-processing output. It includes built-in tracing and observability to track the agent's step-by-step reasoning, which is vital for debugging, and versioning and aliases for controlled rollouts and managing different agent versions in production.
Okay, so the managed nature and integration with knowledge bases seem key. Who is Bedrock Agents best for?
It's ideal for organizations wanting that fully managed experience, offloading all the infrastructure work. Perfect for projects needing rapid development and deployment primarily through configuration, not heavy coding.
Accelerating time to market.
Definitely. Also, if your use case relies heavily on other Bedrock features like knowledge bases or guardrails for safety, and crucially, if your team doesn't have deep in-house ML expertise to build agents from scratch, but still needs robust, production-ready, autonomous capabilities.
What's the implementation process like if it's configuration-based?
It's mainly done through the AWS Management Console or via API calls. You define the agent, create those action groups, specify the APIs it can call, connect it to knowledge bases for data, and then test and refine its behavior using a visual interface.
So much more accessible for maybe business teams or less technical users?
Yes. The idea is to allow teams to rapidly develop and deploy autonomous agents without deep technical expertise in AI model development or infrastructure management.
Let's ground this again. Can you give an example? Maybe something practical, like managing cloud costs. That sounds like a perfect job for an AI assistant, and exactly the kind of thing the AI coach by Anil Naifu could help build.
That's a perfect real-world application described in an AWS blog post. A financial operations FinOps solution using Bedrock's multi-agent framework to create an AI-driven cloud cost management assistant.
How does it work?
It uses a cost-effective Amazon Nova model. There's a central FinOps supervisor agent that delegates tasks to specialized agents. These agents then use action groups to fetch and analyze AWS spend data by using AWS Cost Explorer and generate cost-saving recommendations by using AWS Trusted Advisor.
So it's not just reporting costs, but suggesting savings.
Exactly. And it's built for enterprise use. Secure user access via Cognito, a front end on Amplify, Lambda functions for the actions. Finance teams can just ask in natural language, what did we spend last month? Or find ways to save on EC2 and get detailed answers, recommendations, even forecasts.
That's democratizing complex data analysis through a simple interface. Very powerful.
It really is.
Okay, one more framework to cover. AutoGen. This one comes from Microsoft, right? What's its focus?
Yes, AutoGen is an open source framework from Microsoft. Its core focus is on conversational and collaborative autonomous AI agents. It uses a flexible, asynchronous, event-driven architecture.
Conversational and collaborative. How does that differ from, say, Crew AI?
While Crew AI focuses on predefined roles and tasks in a team structure, AutoGen emphasizes the dialogue itself as the mechanism for reasoning and collaboration.
So the agents figure things out by talking to each other.
In essence, yes. Key features include conversational agents designed for natural language exchanges. Its asynchronous architecture is event-driven, meaning agents react to messages or events without blocking, allowing for very complex parallel workflows.
What about human oversight?
That's a big one. Strong support for human-in-the-loop, allowing optional human participation or intervention in otherwise autonomous processes. This is often crucial for critical tasks.
Can it handle code?
Yes. Specialized code generation and execution capabilities. Agents that can write, run, and even debug code autonomously. Very powerful for automation and development tasks.
Other key features?
Customizable behaviors for flexible agent configuration. Wide foundation model selection, including Amazon Nova on Bedrock. Standardized LLM API integration for Bedrock. OpenAI, Azure OpenAI. And multimodal processing for text and images.
So the conversational approach and human-in-the-loop seem central. When is AutoGen the right choice?
It's particularly good for applications where that natural conversational flow between agents is key to solving the problem. Projects needing both full autonomy and the option for human oversight.
Like quality control or critical decision points.
Exactly. Also, use cases heavily involving autonomous code generation, execution, debugging, and scenarios needing those flexible asynchronous communication patterns for dynamic interactions.
How do you implement it? What does conversational implementation look like?
As their docs show, you create agents that communicate primarily through natural language messages. You set up these asynchronous, event-driven interactions. You can blend full autonomy with points where a human can step in. This allows specialized agents, maybe a planner agent and an executor agent, to collaborate through dialogue. A key benefit is transparency.
How so?
Because the reasoning happens through conversation, it makes the autonomous system's reasoning transparent and accessible to business users. You could literally read the chat log between the agents to understand how a decision was reached, and step in if needed.
Can you give an example of AutoGen in action, something ambitious?
A really interesting one is Agentic AI. It's described as an open-source, generalist, multi-agent system built on AutoGen.
Generalist, meaning it can tackle lots of different problems.
That's the goal. It has a core orchestrator agent that breaks down high-level goals and tracks progress using structured ledgers. Then it delegates subtasks to specialized agents, a web surfer for browsing, a file surfer for local files, a coder, a computer terminal agent for command lines.
So a versatile team coordinated through conversation.
Exactly. And it adapts. If a plan isn't working, it replans dynamically. It's model agnostic, but often uses powerful models like GPT-4o. The remarkable thing is it achieves state-of-the-art performance across benchmarks like GAIA, Assistant Bench, and Wet Arena, all without task-specific tuning.
Without specific tuning. That's impressive.
Yeah.
Shows the power of that collaborative conversational approach.
It really does. It demonstrates AutoGen's potential for creating highly capable, general-purpose AI problem solvers.
Okay, wow. We've covered a lot of ground. Strands agents, LangChain LangGraph, Crew AI, Bedrock agents, AutoGen. 5 distinct frameworks. So the big question, how do you choose? It feels like there's no single best one.
You're absolutely right. It's not about finding the universally best framework. It's about finding the best fit for your specific needs and context. It's truly about organizational fit.
Does the AWS guidance help compare them directly?
Yes, it provides a helpful comparative overview, highlighting the strengths. Let's recap some key points. Amazon Bedrock agents. Strongest AWS integration. Low learning curve. Fully managed. Good general-purpose multi-agent workflow, multimodal support.
Okay, the easy button for AWS users who want managed services.
Pretty much. LangChain LangGraph. Strongest in workflow complexity, those state machines. Multimodal capabilities and broad model API integration, but steeper learning curve and you manage deployment.
The powerhouse for complex custom builds if you have the expertise.
Right. Strands agents. Also strong AWS integration, good multi-agent support, and workflow complexity. Moderate learning curve, self-managed deployment.
A solid AWS native option for more custom control than Bedrock agents.
Yes. AutoGen. Strong multi-agent and conversational support, steep learning curve, self-managed, and currently weaker native AWS integration.
Best for dialogue-driven automation, maybe less tied to AWS specifically.
Good summary.
Oh,
And Crew
great.
AI. Strong multi-agent support via its role-based team structure. Moderate learning curve, self-managed, also weaker direct AWS integration.
Ideal for that explicit team collaboration model.
Exactly.
So, when making the choice, what are the key things to weigh up? The guidance must offer some pointers.
It does. Several key considerations. First, obviously, AWS infrastructure integration. How deeply are you embedded in AWS? If heavily, Strands or Bedrock agents have a natural advantage.
Makes sense. What else?
Foundation, model selection, and LLM API integration. Does the framework support the specific models you want to use? Nova, Claude, OpenAI, etc., and the service interfaces you prefer.
Multimodal requirements. Do you need to handle images, speech, video? LangChain LangGraph and Strands agents seem strong there.
Correct. Then autonomous workflow complexity. How intricate does your agent's reasoning need to be? LangGraph excels here for really complex state machines.
What about teamwork?
Autonomous team collaboration. If you explicitly need agents working together as a team, Crew AI's role-based approach is designed for that.
And the development style.
Autonomous development paradigm. Do you prefer conversational, asynchronous patterns? AutoGen fits that mold.
And the big one, managed versus code.
Right. Managed or code-based approach.
Yeah.
Bedrock agents for managed, minimal coding. The others offer more customization but require more coding and self-management.
And finally, production readiness. Deployment, monitoring, security, scalability, all crucial for real-world use.
Absolutely critical.
Here's an interesting thought. Could organizations use more than one framework? Maybe a hybrid approach.
That's a very real possibility and often a practical one. You might use LangChain for rapid prototyping in one area, Strands agents for a production AWS service in another, maybe Crew AI, for a specific collaborative task.
So it's not necessarily an either-or decision for the entire organization.
Not at all. If we connect this to the bigger picture, the right choice or mix of choices really hinges on the specific use case, your team's skills, existing infrastructure, and how you plan to maintain it long term. There's no single magic bullet.
And navigating those trade-offs, figuring out that optimal mix, that sounds like exactly where strategic guidance, perhaps from resources like the AI Coach by Anil Nathu, becomes really crucial.
Precisely. Making those informed architectural decisions up front is key to long-term success with agentic AI. Okay, let's shift gears now and talk about the second pillar, agentic protocols.
Protocols, right. So we have these powerful frameworks, but how do the agents built with them actually talk to each other or to the tools they need to use? That's where protocols come in.
Exactly. And this raises a really important question. Why are standardized communication protocols so essential? Why not just let each framework do its own thing?
Good question. What's the answer?
It boils down to a few critical things: interoperability, vendor independence, and future-proofing your investments.
Okay, unpack those. Interoperability.
Means different systems can work together seamlessly. Imagine using LangChain to prototype an agent, but deploying the final version using Strands agents for its AWS integration. An open protocol like MCP or A2A lets them communicate using the same language.
So you're not locked into one framework for everything.
Exactly. That's vendor independence. As the AWS guidance puts it, using open protocols reduces dependency on specific AI providers, simplifies integration, and enables you to enhance agent capabilities over time. You gain flexibility.
And future-proofing.
Standards tend to evolve more predictably than proprietary systems. Basing your communication on an open protocol makes it less likely that a sudden change by one vendor will break your entire setup. Plus, well-designed protocols establish consistent security patterns across your whole ecosystem.
So using open protocols sounds strategically smart. What are the specific advantages?
They offer some compelling benefits, especially long-term. You generally get better documentation and transparency, making development and debugging easier. There's often strong community support for help and best practices.
More eyes on the standard.
Right. You get stronger interoperability guarantees across different implementations, better future compatibility, reducing risks of breaking changes, and crucially, the opportunity to contribute, allowing your organization to help shape the protocol's evolution to meet your needs.
Okay, so what are the main players in this agent-to-agent communication space? What protocols should we be aware of?
There are a few key emerging standards. The Model Context Protocol, MCP, is a big one. It was initially proposed by Anthropic in 2024, but AWS is actively supporting and contributing to it. It's recommended for organizations seeking flexible agent collaboration patterns. It uses OAuth for security.
So MCP is a strong contender, especially with AWS backing. What else?
There's Agent-to-Agent, A2A, which has Google's backing. It's aimed at cross-platform ecosystems, but is perhaps newer and has seen somewhat less adoption than MCP so far.
Okay, any others?
The Autogen multi-agent system has its own internal communication mechanisms, backed by Microsoft. Very strong for complex interactions within the Autogen ecosystem, especially for research. And Crew AI also has its own independent implementation, tailored for its role-based team approach.
So different protocols for different needs or ecosystems. How do you actually choose the right one for your specific communication needs?
That's a critical question. It depends heavily on the interaction patterns you need to support.
Interaction patterns, like...
For simple request and response, ask a question, get an answer. MCP with stateless flows works well. Lightweight. For stateful dialogues, ongoing conversations where context matters, MCP with session management is designed for that.
What about multiple agents collaborating?
For multi-agent collaboration, intricate back and forth, MCP's interagent capabilities are strong, as is Autogen's conversational approach. For structured team-based workflows like Crew AI's Model MCP interagent, Crew AI itself, or Autogen could work, depending on how you want to structure that hierarchy and delegation.
So the pattern matters. What else influences the choice?
Several technical and organizational things. The security model is paramount. Does it meet your requirements? MCP's use of OAuth 2.0 is a strong point. The deployment environment, distributed cloud versus single machine. Ecosystem compatibility. How well does it integrate with your chosen frameworks like Strands or LangChain? And scalability needs, do you need high throughput, maybe requiring streaming like MCP offers?
It also seems like the type of organization you are might influence the choice.
Right.
Enterprise versus startup.
Absolutely. The AWS guidance gives specific advice here. For enterprises, the strong recommendation is to prioritize open protocols like MCP for strategic long-term stability. Use abstraction layers if you have to use proprietary protocols to ease future migration, and maybe even participate in standards development.
Okay. What about smaller companies, startups, SMBs?
For them, it's about balancing speed and flexibility. Maybe start with a well-supported proprietary protocol within a framework to move fast. But crucially, plan a migration path to open standards as you scale. Keep an eye on adoption trends. Managed services can also help here, abstracting away the protocol details.
And for government or regulated industries, security and standards must be key.
Even more so, the emphasis is heavily on open standards to avoid vendor lock-in and ensure long-term access. Prioritize strong security models, robust authentication. Think carefully about data sovereignty implications. Where does the communication happen? And meticulous documentation of all choices is essential for compliance.
That context-specific advice is really valuable. It shows that protocol selection isn't just technical, it's strategic. This level of nuanced guidance is something the AI coach by Anil Nathu often provides.
Exactly. It connects the tech choice to the business reality.
So let's say you've considered all this. What's the practical game plan for actually implementing these protocols effectively in your architecture?
Connecting this back to the bigger picture of building a resilient AI system, the strategic approach involves a few key steps. 1. Start with standards alignment. Adopt open protocols like MCP wherever feasible. It's the best long-term bet. 2. Create abstraction layers. Build adapters between your systems and the specific protocols. Don't tightly couple your core logic to one protocol implementation. This gives you flexibility later. 3. Contribute to open standards if you can. Participate in the communities. Help shape the protocols to meet real-world needs. 4. Monitor protocol evolution. The space moves fast. Stay informed about updates and emerging standards. And 5. Test interoperability regularly. Make sure your different components using the protocol still work together correctly, especially after updates.
Okay, that's a solid plan. You mentioned MCP several times as a strong foundation, especially with AWS support. If an organization decides to go with MCP, where do they practically begin?
Good question. To get started effectively with MCP, a few concrete actions are recommended. First, explore its implementations and frameworks like the Strands Agents SDK. It provides a production-ready example.
Look at working code.
Exactly. Second, really dig into the official model context protocol technical documentation. Understand the specs, the message formats, the compatibilities.
Read the manual.
You got it. Third, check out that AWS open source blog post, Open Protocols for Agent Interoperability Part 1, Inter-Agent Communication on MCP. It gives practical context.
Learn from AWS's experience.
Right. And finally, join the MCP community. Engage, ask questions, learn from others, maybe even contribute. This keeps you connected.
So explore implementations, read the docs, read the blog, join the community.
That's a great starting point. MCP provides that powerful standard communication layer for both agent-to-tool and agent-to-agent interactions. It handles simple requests and complex, stateful dialogues. Adopting it strategically positions you to build agent systems that are, as the guidance says, flexible, interoperable, and adaptable as AI technology evolves.
And again, for specific resources and step-by-step guidance on implementing protocols like MCP effectively, checking out the AI Coach by Anil Nathu would be a smart move.
Definitely. Practical implementation guidance is key.
All right, we've covered frameworks, the brain, and protocols, the language. Now let's talk about the third pillar, tools, the hands. It feels like agents are only as useful as the things they can actually do, right? The tools they have access to.
That's absolutely right. The AWS guidance nails this, stating that the right tool integration strategy directly impacts your agent's capabilities, security posture, and long-term flexibility. Tools are critical.
So what kinds of tools are we talking about here? Are there different categories?
Yes, the guidance breaks them down into 3 main categories, which is helpful for understanding the landscape. First, protocol-based tools. These are tools designed to communicate with agents using those standardized protocols we just discussed.
Like MCP.
Exactly. MCP tools are a prime example. OpenAI's function calling and Anthropic's tool definitions also fit here. They're built for interoperability across different agent systems.
Okay, protocol-based. What's the second category?
Framework native tools. These are tools built directly into a specific agent framework.
Like the examples we touched on earlier, Strands Agents, Python tools, LangChain tools.
Precisely. Lemma index tools also fall here. They offer tight integration within their framework, but often come with that trade-off of being less portable, potential framework lock-in.
Got it. And the third category, you mentioned meta tools.
Yes, meta tools. These are really interesting. They don't directly interact with the outside world like calling an API.
Yeah.
Instead, they enhance the agent's internal workings by implementing core agentic patterns.
So tools the agent uses on itself.
Kind of. Tools for managing its own workflow, coordinating its internal components, managing its memory. They add layers of intelligence within the agent.
Okay, that's a useful breakdown. Protocol-based, framework-native, and meta tools. Let's dive deeper into the protocol-based ones, especially using MCP. You said MCP isn't just for agent-to-agent talk.
Correct. AWS has strategically embraced MCP for tool integration too. It provides a standardized, secure way for agents to invoke tools.
How are these MCP tools deployed? Are there different ways?
Yes, MCP offers flexibility here with three main deployment models. The simplest is local Studio-based. The tool runs in the same process as the agent.
Good for development or simple stuff?
Exactly. Ideal for dev, testing, very basic tools, quick to implement, no network overhead.
What's the next step up?
Local server sent events, SSE-based. The tool still runs on the same machine, but communicates with the agent over local HTTP using SSE. This gives better isolation between the tool and agent processes, still with low latency. Good for more complex local tools where you want that separation.
And for production?
That's where remote SSE-based tools come in. The tool runs on a completely separate server, potentially shared by many agents. This is the model for production environments.
Why remote for production?
Scalability, central management, and enhanced security. You can deploy, manage, and secure these tools independently in your cloud environment.
Are there official SDKs to help build these MCP tools?
Yes, there are official MCP SDKs for Python, which is quite comprehensive, TypeScript, great for web apps, and Java, important for enterprise. These SDKs provide consistent implementations of the protocol, making it easier to build compatible tools.
And Strands Agents uses this.
Yes, the Strands Agents SDK offers a straightforward way to create and use MCP-compatible tools, serving as a good practical example.
What about securing these tools? If an agent can call an external tool, that sounds like a potential security risk.
Absolutely. Security is paramount. The MCP security model is designed to address this comprehensively.
How?
It incorporates OAuth 2.0 to 2.1. Authentication, the industry standard ensuring only authorized agents can call specific tools. It supports fine-grained permission scoping, adhering to the principle of least privilege. There's also tool capability discovery, so agents can dynamically find out what tools are available and what they can do. And structured error handling for reliability. This robust security framework is vital for enterprise trust.
Okay, for teams wanting to build MCP tools, where should they start? What are the practical first steps?
Similar to starting with MCP for agent communication, explore the Strands Agents SDK implementation. Read the official MCP technical docs carefully. Use the practical examples from the AWS open source blog, and maybe start simple. Build a basic local tool first to understand the mechanics, then graduate to remote tools with network and security considerations. And again, engaging with the MCP community is always beneficial.
Makes sense. Now, while MCP offers that flexibility and standardization, you mentioned framework native tools can sometimes be faster or easier for specific tasks.
Yes, there's definitely a place for them, especially for rapid development or tightly coupled functions. The Strands Agents SDK, for instance, has these lightweight Python tools that require minimal code.
Right, you gave that weather tool example earlier, just a Python function with a docstring.
Exactly. The docstring becomes the documentation for the agent.
Mm-hmm.
Super efficient. At tool, define the function, write the docstring, implement the logic, and the agent understands it.
And other frameworks have similar native tool approaches.
Yes. Autogen uses function definitions, well integrated with its multi-agent system. LangChain uses Python classes for tools and have that huge ecosystem, but you need to be mindful of potential lock-in if you rely too heavily on its specific structures. LamiIndex uses Python functions too, but is very focused on data operations within its own ecosystem.
So the bottom line seems to be framework native tools are great for speed and prototyping within a specific framework.
But for production systems needing broader interoperability, long-term flexibility, and avoiding vendor lock-in, MCP tools are generally the more strategic, future-proof choice.
Got it. Okay, let's circle back to those meta tools. Tools the agent uses internally. Can you elaborate on those?
Right. They don't call external APIs, but they implement core agentic patterns to make the agent smarter or more organized internally.
What kinds of patterns?
We can group them into three types. First, workflow meta tools. These manage the agent's execution flow. Think state management, handling branching logic if X do Y, else do Z, implementing retry mechanisms for temporary failures. Frameworks like LangGraph and Strands Agents have these built in.
Helping the agent navigate complex tasks.
Exactly. Second, Agent graph meta tools. These focus on coordinating multiple agents working together. Things like task delegation, assigning subtasks, result aggregation, combining outputs, conflict resolution. Autogen and Crew AI, with their multi-agent focus, specialize here.
Managing the AI team internally.
Precisely. And third, memory meta tools. These provide the mechanisms for storing and retrieving information, the agent's memory, managing conversation history, interacting with knowledge bases, using vector stores for semantic search. And importantly, MCP's resource system offers a way to standardize how these memory tools work across different systems.
Okay, that clarifies meta tools. So bringing it all together, protocol-based, framework-native meta tools, how do you actually build a robust, flexible tool ecosystem? What's the recommended strategy?
If we connect this to the bigger picture of designing a solid agentic system, the AWS guidance outlines a clear strategic approach. It's about using the right type of tool for the right job, prioritizing open standards where it matters most.
What's the first principle?
Adopt MCP as your foundation for tool communication. Use it for strategic tools, security-sensitive ones, and remote tools in production. It gives you that standardized, secure connection.
But native tools still have a place.
Yes. Use framework-native tools when appropriate, for rapid prototyping, simple non-critical functions, or when leveraging unique framework capabilities is key. Just be aware of the lock-in potential.
And the internal tools?
Implement meta tools to handle complex internal workflows and intelligence. Start simple, add complexity as needed, and try to standardize the interfaces your agents use to interact with these internal capabilities.
And always think ahead.
Absolutely. Plan for evolution. Document tool interfaces clearly, use abstraction layers, have a plan for migrating from proprietary tools to open standards over time. Future-proofing is key.
No discussion about tools that interact with systems and data is complete without talking security again. This feels absolutely critical.
It raises the most critical question, doesn't it? How does tool integration impact your security posture? The guidance lays out clear best practices.
Like what? Authentication.
Definitely. Authentication and authorization. Use robust methods like OAuth 2.0, 2.1 for remote tools. Strictly enforce the principle of least privilege. Give tools only the permissions they absolutely need. Rotate credentials regularly.
What about the data itself?
Data protection is crucial. Validate all inputs and outputs using schemas to prevent bad data or injection attacks. Encrypt sensitive data in transit using TLS. Practice data minimization, only pass the necessary data to the tool.
And keeping an eye on things.
Monitoring and auditing. Log all tool invocations for a clear audit trail. Monitor for anomalies or suspicious usage patterns. Implement rate limiting to prevent abuse. The MCP security model helps address many of these inherently.
These practices feel non-negotiable for building trust.
They are absolutely critical for building trustworthy, resilient, agentic AI systems you can deploy confidently. And for really comprehensive guidance on embedding these secure AI practices from the start, the AI Coach by Anil Nathu is an excellent resource. They focus on making security foundational, not an afterthought.
Exactly. Building secure, reliable systems requires that proactive approach.
Okay.
Hashtag tech, hashtag action plan and conclusion.
Okay, wow. Frameworks, protocols, tools. We've really unpacked the core components of agentic AI based on this AWS guidance. So what does this all mean for our listeners? What's the big takeaway?
I think the main takeaway from the AWS prescriptive guidance from Aaron Semf and Joshua Samuel is that these three pillars frameworks providing the foundation, protocols enabling communication, and tools extending capabilities are the essential building blocks. Organizations that invest in understanding and building expertise with these components now are going to be really well positioned to build increasingly autonomous, intelligent agents that deliver significant business value.
It's about building that foundational knowledge. Exactly. And specifically on protocols, the choice is strategic. It's about balancing immediate needs with that long-term flexibility. MCP stands out as a strong foundation, open standard, growing ecosystem, solid support for both agent-to-agent and agent-to-tool communication, plus AWS's active involvement.
What about the future? Where is this all heading?
Well, we can definitely expect more interoperability between systems. Continued standardization around protocols like MCP seems likely, and more sophisticated orchestration capabilities within frameworks as they mature. Things are moving fast, but the core principles remain.
Which leads to a really interesting question for everyone listening. Here's something to think about. As these AI agents get more sophisticated, more autonomous, How will you use them? How could they transform your workflows, your decisions, maybe even your entire business model?
That's the provocative thought, isn't it? What complex problem in your world, one that seems maybe too hard or too time-consuming now, could an autonomous AI crew potentially solve?
Hmm.
It forces you to think beyond simple automation.
Absolutely. So for those inspired to move from just thinking about it to actually doing something, let's lay out a practical action plan based on everything we've discussed.
Sounds good. Let's break it down into steps.
Mm.
Step 1, assess your needs frameworks. Start by really looking at your specific use case. What's your existing AWS setup like? What skills does your team have? Then, based on our comparison, consider Strands agents if you're deep in AWS and need that native integration for production autonomy.
Okay.
Consider LangChain LangGraph for complex multi-step reasoning graph workflows, assuming you have Python ML skills.
Right.
Think about Crew AI if your problem naturally suits that collaborative, role-based team approach.
Makes sense.
Look at Amazon Bedrock agents if you want that fully managed configuration-driven experience, maybe with limited in-house AI dev resources.
A simpler path.
And consider AutoGen if you need conversational agents, human in the loop, or autonomous coding. And remember,
A hybrid approach might be best.
exactly, don't feel locked into just one for everything. Match the framework to the specific need.
Okay, step 1. Assess framework needs. What's step 2?
Step 2, prioritize interoperability protocols. Long-term flexibility comes from open standards. So the action here is, start by adopting Model Context Protocol, MCP, as your foundational standard for agent communication.
Make MCP the default choice.
Pretty much. Then, actively explore how your chosen frameworks actually use or integrate with MCP. And critically, build big abstraction layers in your architecture. Don't tie your core logic directly to a specific protocol implementation. This saves you headaches down the road.
Step 3. Tools.
Step 3, build your tool ecosystem. Tools are how agents get things done. Action. First, identify all the external systems, APIs, data sources your agents need to touch. Then develop MCP-based tools for the strategic, secure, remote production integrations.
MCP for the important external stuff.
Right. Strategically use framework-native tools for rapid prototyping or simple, non-critical things where framework integration's easy. And integrate meta tools, workflow, agent graph, memory to boost your agent's internal intelligence and coordination.
Okay. Step 4 must be security.
Absolutely. Step 4, implement security best practices from day 1. This cannot be an afterthought. Action. Apply robust access controls like OAuth 2.02.1. Enforce least privilege rigorously. Implement strict input-output validation and encrypt sensitive data. And set up comprehensive logging, monitoring, and auditing for all tool use. You need that visibility and control.
Foundational security. What's the final step?
Step 5, stay informed and engage. This field is moving incredibly fast. Action. Actively monitor updates and emerging standards. Follow the key players. Read the research. Engage with the open source communities, MCP, Crew AI, AutoGen, etc. Contribute, learn, ask questions, and continuously test the interoperability and performance of your systems as things evolve. Stay curious and stay engaged.
Assess needs, prioritize interoperability, build the tool ecosystem, implement security, stay informed. That's a solid plan.
It provides a structured way to approach building effective and sustainable agentic AI solutions. #outro.
This has been an incredibly insightful deep dive. Thank you for breaking down this complex topic of agentic AI frameworks, protocols, and tools on AWS.
My pleasure. It's a fascinating and rapidly evolving area.
Thank you for joining us today. Visit the AI Coach website for more AI insights.